Right, so let's have a look at that. 20. Linear functions. Alright, so a couple of extension topic formulas that you need to know in this section. So we've got two lines and we want to know the angle between them. So there's a diagram underneath the box at the top with the formula. Okay, but the formula you need to know is tan theta equals tan of alpha take away tan of beta. Oh sorry, no, that's the wrong formula, sorry. That's another formula that you will learn. So tan theta is the absolute value of m1 take away m2 over 1 plus m1 and m2. Right, m1 and m2 is the gradient of your two lines. Okay, so basically you have the intersection of two lines and we want to work out the angle between them.
Would that make 10, would it be 10 m1 take away m2 as theta? Because of your 10x plus y, 10x minus y?
Yep, and that's how we're going to derive the proof. Okay, so proof, good that you're thinking that already. 7.1. Right. So, using your mathematics geometry. Alright, look at the triangle there. We've got three angles. We've got alpha, we've got theta, and we've got beta. So I want an equation relating the three. Using your mathematics geometry. What's the simple version of that, Golden?
What do we find?
Hey?
What do we find?
I want a relation between alpha, beta, and theta.
Alpha plus beta.
Alpha plus beta equals beta.
Alpha plus beta is equal to the external angle.
Yeah.
Yes, the two internal angles, yes, the exterior angle result. Okay, so I want theta the subject of the equation. Okay, and I'm going to introduce a tan to both sides. Now, one other thing that we did in mathematics is finding the gradient given the angle that it makes with the positive x-axis. Okay, so we let m1 is tan of beta and m2 is tan of alpha. So this is something that Mrs. Whatever prefix is, thing taught you when I was away last 2 weeks. Okay, so the gradient of a line, we take the angle that it makes to the positive x-axis of those two lines, and that will give you the gradient. Okay, so going back to Makala's thought process, so tan theta, so it'll be tan beta, take away tan alpha over 1 plus tan beta tan alpha. Okay. So we've already set m1 and m2, so it equals m1 take away m2 over 1 plus m1 m2. So basically you add the two angles, the two gradients, together. You do the difference of them on the top, and then 1 plus the product on the bottom. Right. Now, other part of the formula is the absolute value. Okay, why do we need the absolute value as part of this formula?
You need a formula.
So basically I want what's inside this section, I need it positive, so I can calculate the tan of the positive angle. Okay, now this will give you the angle in the first quadrant. So in other words, this will give you an acute angle. Alright, so if you remember your quadrants work, okay, so an angle between 0 and 90, sine, cos and tan are all positive. Okay, anything that's greater than 90, less than 180, only sine is positive. Okay, so that means tan is negative in the second quadrant. Alright, remember that when I ask you a question later on. So, there's the proof. Examples. And of course, we can't have an angle greater, or we can't have anything greater than or equal to 180 for one angle in the triangle. Okay, when you think about forming a triangle. Alright, find the acute angle between the line. (3x plus 2y equals 7) and 2x take away 5y plus 1 equals 0. So we have two linear equations, so that will form straight line when we plot them onto the number plane. Okay, so what do I need to do in order to find the acute angle between them? Find the gradients of both the lines. Okay, we've got a couple of options here. Alright, so we can either convert them all to y equals mx plus b form, and we read the coefficient of x to get the gradient. Or, if you remember your formulas, when we had it in the form ax plus b, y plus c equals 0, and one of the formulas that you should have gone through, you're getting the coefficient to get the value of the gradient. I think it's, it'll be negative a over b. Pretty sure. Well, we can derive it, can't we? Yeah, so you think about it, you move this over to the other side, these two over to the other side, become the negative ax, and then you have to divide both sides by b. Alright? So you either need to convert it to this form, or you need to remember an extra formula. Okay, so I know what I would prefer. Okay, use my quick algebra skills to be able to get in this form, because I know that's the gradient. That's from your last 2 years' work when you've calculated, when you've done this sort of work. Okay, I'm not going to necessarily remember this sort of formula. Okay, so let's convert them both. So we've got 2y is equal to negative 3x plus 7. So y is going to be negative 3 over 2x. So m1 is going to be negative 3 on 2. So 5y is equal to 2x plus 1, and y is going to be 2x over 5 plus 1 over 5. Okay, you don't really need to do the constant bit, you just need to get to the stage where you've got your gradient. Okay, so m2 is going to be 2/5. Okay, so it doesn't matter which one of them m1, m2 because of the absolute values. Alright, you will need the positive answer. Right, it will just depend on the values when you put them in the numerator, which one greater or smaller. Right, so tan theta is the absolute value of m1, take away m2, over 1 plus m1, m2. Right, I'll be writing this down, help you to remember the formulas. Otherwise, you'll need to be able to quickly derive it. And remembering your trig work as well. Right, so theta is going to be tan inverse. Okay, so we're calculating that angle that's formed by those two lines. Negative 3 over 2, take away 2 over 5, over 1 plus negative 3 over 2 times 2/5. Right, so at this point, I would be putting this part in the calculator to make sure you get it positive, okay? I'm not sure if there's a setting on your calculator that will return absolute value.
Oh, wait, yeah, there is. There's the absolute
Yeah.
value.
Is there? Well, I haven't actually used it myself yet, so maybe I'll learn something today.
Yes, that adds.
Have you actually used it before?
No.
No? Well, this would be the lesson where we use that button.
Are you doing it in parts?
Yeah, I do it in parts and put it all together.
So you could send it to me. I got 78.11. I got 78 degrees and 7 minutes.
Oh, cool. Excellent.
37?
I got 78.
Yeah, I've learned something today.
How did you get that?
What's the answer?
I'll try it. 3 over 2 minus 2 over 5. Right
Did you 10 inwards?
there. Yes.
You sure?
Yes. 3 over 2. Don't you hate it when you forget to put in like a fraction?
Okay, I've got 78 degrees, 6 minutes.
Right.
2 over 5.
But did you round, sir?
Hey,
Did you round?
38 degrees, 7 minutes.
Ah.
To specify in the question, the nearest degree. Okay, 78 degrees. You got it? Is your calculator set to degree mode? Because you're going to have a hard time in your HSC because you have to convert your calculator from degrees mode to radians mode. And then if you want to work with degrees, you have to convert that to degrees.
I don't know how to put it in easily.
Just put the whole thing in.
That's what I did, and it gave me a syntax error.
You missed a bracket or something. You tried.
We couldn't ask more from you, couldn't we? Okay. I'd actually put the fraction in first, put the overall fraction, and then put the actual fraction component in there. Okay. While you're working it out, 2 maybe
3
Yay!
got it?
Yep.
Alright, so I would recommend a quick sketch, okay, because you've got it in the form mx plus b, and we can quickly sketch using the y-intercept and the gradient. Okay, so between the two lines, because it's very close to 90, it's not quite so obvious which one's the acute angle. Okay, but I'm assuming this one here. Considering the gradient, okay, you've got one greater than 1 and one that's close to 0. Alright, so you consider a bit of a spread between those two lines, and that's what you're calculating. Okay, so to ensure that your answer makes sense in terms of the diagram, okay, because I've already got in this form, I'd be doing a quick sketch. Just verifying, yes, that would be an appropriate answer for that question, and an appropriate answer for that question. You had a puzzled look on your face.
I can't remember. I never learnt how to figure out what the line was in the.
Sketch it from like
What?
how to sketch it from like
No, like the line 3x plus like 2y. I don't know what it looks like on a.
Yeah, so I put it in this form to sketch it.
Okay.
Okay, that's what I do. That's what you need to do as well.
I don't understand what goes where.
For this form,
Yeah.
the constant is the y-intercept.
Okay, yep.
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 Because when x is 0,
Right. So intercept and then y 0
so you
then.
substitute x is 0 and you're left with the constant number
Yeah.
for the y-intercept, and the gradient is 2 over 5. So from the y-intercept, so very close to 0, okay, you go up the rise over the run. You go up 2 and then you run 5.
Yeah.
That's the gradient. So you go up 2 along 5.
Okay, yep, yep.
Yep, so for example, y equals 3x plus 2.
Were we ever taught that?
I think we had Kish.
Oh.
Yeah.
So the y-intercept when x is 0, okay, so we've got on the x-axis, we're substituting 0 there, makes the y value 2. So we've got 2 at that point there for the y-intercept. And then the gradient, m, is the rise over the run, which is 3. That means the run has to be 1.
Yep.
Alright, that means you go up 3, 1, 2, 3, and then you run 1. From there, 1, 2, 3, and you run 1.
Okay, fair enough. Yeah.
Yep.
Yeah, that was it.
I'll just wait for your payback, Robin. I'll do something very simple and she'll be like, what are you wishing at? Okay, so I don't do that form, always commit it and I'll do it quickly in that form. The only way you could really do that efficiently is probably through a table of values. And even then it's not going to be quite so efficient to do it. You might as well put it in this form so that you can use the table of values. Right? So that's my personal way of doing it. Okay, so example A was to find the acute angle, example B, find the obtuse angle. Okay, so you're thinking about this, we just found that acute angle there. For that example, alright, if I wanted the obtuse angle, I would need that one, wouldn't I? Or I would need that one for the obtuse angle. So thinking about what you need to do at the end. Right, so x plus 2y take away 5 is 0. And x take away 3y plus 3 0. So the same concept, Mikhaila. If I want to find the gradient of this, I'm going to write in y going to complete form. Alright, that's how I'm going to do it. Alright, so we're going to find the gradient of both of those. So take negative x plus 5. So negative half x plus 5 over 2. Get y the subject of that equation. And same with this side. So 3y can be x plus 3. Because 3y is already negative. Which we know then swapping the sides. Y is going to be x over 3 plus 1. Okay, so this is very annoying template here. Alright, getting this two-step equation. So M1 is going to be negative a half, and M2 is going to be 2. Right, so before we calculate it, let's have another go at sketching it. See if you understood that concept. Right, so just a rough sketch of these two lines with those two gradients and y-intercepts. Right, so y-intercept is 5 over 2, so 2.5. So plot that point first on the y-axis. And then the gradient is negative 1 over 2. So you've got a rise of negative 1 and a run of 2. That means you're going down 1, then across 2. Down 1, across 2. Point will be somewhere in relation to there. So again, down 1, and then across 2. That's your next point. Down 1, across 2. So the line will be like that for the first one. Yep. The second one, so y equals x over 3 plus 1. We start with the y-intercept, a positive 1. y-intercept, and then the gradient is 1 over 3. So that would rise of 1, then a run of 3. So 1, 2, 3. 1, 2, 3. Something like that. Right, so and theta is the absolute value of m1, take away m2, over 1 plus m1 m2. Doesn't matter which one you make m1s and 2s, the absolute value will take care of that for you. What do we get?
45.
You could be right. I could be
I
right.
got 11 degrees.
I would actually support some college being some nice rebel. Well, looking at the lines, the acute angle, I would suggest going to be reasonably small.
I'm standing by enough to 45 degrees.
Oh no.
Do it with it.
Oh my word.
Push
Yeah,
did
I
you
got
clear
it.
it?
Yeah, I got it.
Good.
I got it again.
Do what you did.
Robert.
What?
What? That 10:45. What have you done?
Can you invest?
Yeah.
What you?
Like that.
Wait, you put yours in. You didn't put yours in brackets. I put mine in brackets.
Mine is in brackets, isn't it?
No, I put brackets in and now it's. We need like exact numbers. Is it top one? The top one's take away. Ha!
Oh.
I got it.
So it is good.
Is that negative? Is it negative
It's
for
negative.
third?
It's M1 negative.
Is it a negative for third? No, no. Yeah.
45 exactly.
Yep.
Really? No, it's exactly 45 degrees.
Exactly 45.
Wow.
Did you make that question?
Not often that happens.
What a coincidence.
Alright, now the point is, this is going to be the acute angle. Alright, so I want the obtuse angle, so the angle that's greater than 90. Alright, so I need that one. How am I going to work that out?
180 take away.
Good. Okay. Obtuse angle. Now the reason why I asked you is exactly 45 because if it wasn't, you're not rounding at this point, you're rounding after you've done that calculation. So 45 point, whatever the decimal, you would need to take that away from 180 and then round your final answer. Okay? And 35 Chris. Yeah. That was completely coincidental. Or was that just good predicting mathematics?
You'd like to think.
I'll let you decide. Okay, any questions on that concept? Okay, so very reasonably straightforward. The only difference in the questions you will get, you will be given the angle, and you will need to work out one of the gradients. Okay, so it's just going backwards. Alright, I'm going to let you try that when you get up to the exercise. Right, any questions? Okay, we're all happy with that one? Right, let's start with the next one. I don't expect to get it done today, so let's get started. Okay, the other concept that you need to know in this section of linear function is ratios. Alright, so basically you are given 2 points and you need to find the point that divides the interval of those 2 original points into a certain ratio. Okay, so the following formula determines a point in an interval that follows a ratio from either end. Okay, so coordinates of the point P that divide the interval between the point x1, y1 and x2, y2 in the ratio of m to n, respectively, are given by the following formulas there. X is equal to mx2 plus nx1 all over m plus n, and y is my2 plus my1 over m plus 2. M plus n. And I'll talk about the rest of that box in a moment. Alright, so proof. Okay, so this is really the difference between mathematics students and extension students. Okay, so the extension students are really are seeing how formulas work. Okay, this is why I've been showing you everything, pretty much everything so far. Okay, so that will give you, and hopefully the idea is, well, one, you're supposed to know them, technically, and two, you're actually seeing how things work. Okay, so you're not just taking a formula and assuming that is correct. Okay, you want to see why it works, because we're going to give you some principles that you already know in order to improve on our understanding. Right, so, full sketch. So, we have point A, point B, so point B, x2, y2, point A, x1, y1. So you have 2 points, typical question, so we're giving you 2 points. Right, so you can imagine the interval that joins them. What you are required to do is find the point P, or x, y, that divides that interval into the ratio m, n. Sorry, not quite there yet. I'll introduce that elsewhere. Right? So you're finding that interval to find, so using that ratio to find that interval. Yeah, that's right. M. So put that back in there. Yep. Record it. M to n. Right. So that was 1 to 2. Right. For example, so this is 1. This will be 2. The point will be divided. The point P will be close to B, wouldn't it? Right. So you're thinking about breaking up into 3 equal parts. Because 1 plus 2 is 3. It would be 2 parts from M. 2 parts from M and 1 part from N. Right. To get the actual value. Right, so in your diagram you have been given the right angle triangle. And drop 2 perpendiculars down like that. Equals point C equals point D. Right, what's the x value point A? In terms of what's in the diagram. What's the x value of point A?
The x value of point A, x minus x1.
Yep, that's what we're going to do. So x is the x value of D, and x2 is the x value of C. Alright, now in the geometry section when we did similar triangles, okay, the other part was the intersection of parallel lines with the transversal and the relationship between them. Okay, so we have 2 parallel lines because we have dropped 2 perpendiculars down here. Okay, so from the concept of mathematics, the ratio AP over PB must equal AD over BC. Alright, so that distance over that distance is equal to the same ratio as that distance over that distance. Alright, that's what we learned in mathematics. Right, how long is AP? Alright, for the ratio, we have distance M from the diagram. How long PB? What's an expression for the length of AD?
X, take away x1.
X plus x1.
X, take away x1.
Yep, that's right, you got it.
Yeah.
With overall distance is X,
X plus x1.
and then you want to take away this distance here, which is X1,
Yeah.
to get that remaining distance there.
X plus x1.
No, the way I'm seeing it is taking x all the way back to 0 and then adding it back on to come back.
And you get a negative. Why did you do that? It's so difficult. It's x take away x1 go.
Okay, so this distance from here to here is X.
Yeah.
Yes? This distance from here to here is X1.
Yeah.
Okay, I want the distance from here to here.
Okay.
So I'm going to do that overall distance here. Take away this distance here. That will take that part of it out, and I'm left with what's next. Yes? That's so X, take away X1 for the distance AD. And how long is DC?
X2 take away x.
Brilliant. Go.
All the money. Alright, so think about the formula. We need X is mx2 plus nx1 over m plus n. So we're up to here. What's the suggestion of what we need to do?
Cross multiply.
Right.
Yes, cross multiply.
Good. So n outside of x2 take away x is going to equal to n x take away x1. Equal signs, so we don't need to introduce any more denominators, we just cross multiply. What's next?
Get them on the same side, no?
What was before that?
Divide by n.
It's just more together.
Divide by n, then you got x minus x1, then you just put the x1 over the other side.
Okay, between both sides. What's next? Thinking about our end result.
Divide by n. No.
Nope.
Put the nx1 over the other side.
So we are getting x's onto one side. So I'm going to move this over that side.
Yeah.
And then
So
you,
n
yeah, and then you
equals
divide
2.
by m and n.
Yep. This. So nx plus nx.
Right.
That's how it works. Okay, so like I said, we're not just looking at formulas, we are drawing stuff so you can see how these things work. And also brushing up on a lot of skills that we should already know. Improve on your understanding. Okay? Now it's going to be a very similar setup to wires. Okay, if you go up this way and do a similar thing in terms of getting these ready up here. Do the same sort of thing. Okay? I'm not going to go through that. Okay, I think we can both see that's going to work. Right, and then similarly for y. So similarly for ny2 plus ny1 over n plus n will give you the value of y. That's by the interval. Pretty cool, I reckon. Seeing how things work, not just assuming, not just following the formula. So examples. Apply them. Define the coordinates of the point P, which divides the interval AB internally in the ratio 4 to 9, with A as 2, 3 and B as 5, minus 7. So, these formula that you're given, they are internally point, right? And we'll talk about external in a moment. To remember the process, set up the questions as following. So, you put 2 points up here, the 1, 4, and 2, 1, two, 3, and 5, -7. Right, so you put them side by side like that, and then the ratio, put them underneath. Like that. Okay, the reason why, so underneath, x1, y1, x2, y2, and n. They're variables. Right, put an arrow pointing this side, and an arrow pointing that side. Opposite side. Okay, so the formula is mx2, take the left ratio, multiply it with the 2 points on the right for where they belong, okay, and then take the right ratio of the right and multiply it by what's on the left. Okay, so if you draw those arrows, they'll help you to remember the process. Alright, so x is going to be, so from this 4 and the 9, so it's going to be n x2 plus n x1 over m plus n. So it's going to be 4 times the x value of the right coordinate, so 4 times 5, plus the right side of the ratio multiplied with the x value of the left coordinate, 9 times 2. And then you add the two numbers in the ratio together. So often the point won't simplify to an integer. Often you're going to have a fraction. Okay. Well, in terms of the question, it hasn't actually asked you what format they want it. Okay, so you could leave it like this, really. Okay, so 13 into 38 goes, well, 13 times 3, 39. So it would really be 2 and 12 over 13 as the value of the point. Okay. Right, so I'm just giving you a number just to get an idea of what we're doing when we draw a diagram. Right, so y is going to be n y2 plus n y1 over n plus m. Right, and you follow your arrows again. This time you're using your y value of your coordinate. So 4 times the y value to the left, the right, plus 9 times the y value of the left. So 4 times negative 7 plus 9 times 3 over 4 plus 9. Negative 28 plus 27 is 1 over 13. Okay, so therefore, P is the point 2 and 12 over 13, negative 1 on 13. Okay, that's how you need to finish the question, okay? Not really. So we've got our points. So 2, 3. That was there. That was A. And 5, minus 7. So we're down here somewhere. B. So we have the interval that joins those two. Okay, in the ratio 4 to 9. So 4 plus 9 is 13. So you think of it as broken up into 13 equal instalments. Okay, and the distance from this side is 4, and the distance from this side is 9. We've got 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so that distance is 4 units, and that distance is 9 units. Okay, and that's the point P. 2 and 12 on 13, and negative 1 on 13. Does that seem reasonable? That's what you're working on. That's what you're working out, right? Right, any questions on the process? Next one. Alright, B. Find the coordinates of the point P, X, Y, which divide interval AB externally. Right? Externally. In the ratio 1 to 3, with A over 1, 4, and B 5, 2. Just do a quick sketch before we continue on this question, just leave your space for the ratio. Right, so 1, 4 and 5, 2. Yeah. Okay.
She's asking if I wanted the copy.
Okay, so that's A, B. When we talk about externally, okay, so now we are not inside the interval. Externally means it's going to be outside the interval, okay? So the point is going to be along the same line of path, but it's either going to be out here or out there, okay?
So it's the same thing, it's halfway in the middle, or the ratio, however the ratio, but it's the other side.
Essentially, yeah. So, if we consider this from A, 1, 2, what was the ratio?
3.
1 to 3. So, you go out 3, that side, and then you will come back 1, back to the interval to get that point there. Alright? From point B, right, you go 1, 2, 3, so out of the interval, and then back the 1, get back inside onto the endpoint there. Okay, so that's what we're doing there. So, to answer this question, we write down the ratio, 1 to 3. But what you need to do is either number in the ratio, we will put a -1. Okay, that's all you need to do. Okay, so internally, we use the formulas as they are. When it says externally, you need to change 1, not both, just 1 of your numbers in the ratio as a negative. Okay? Now, also, you're going to have 2 possible answers, aren't we? Alright? And that will just depend on where you put the minus sign. Alright? So unless you're told any further details of the question itself, okay, I have to mark both answers that you could get as correct. Okay? Right, so after you set it up, you draw your arrows. So when you got the ratio question, as soon as you put the arrow, that's going to help you to remember this formula and the process of getting the formula. So x mx2 plus n x1 over n plus n, so you use the same formulas. Okay, you're just going to have to substitute in the negative. Right, so m is the left side of the ratio, the -1, times the value of the right coordinate, of the x value, sorry, because we're working on the x point, plus the value of the right side of the ratio used in conjunction with the left coordinate. And then, of course, when we add them together, it's going to be -1. Oh, sorry. So -5 plus 3, we have -2 on -1 plus 3, which is 2. So the x value can be -1. Right, so we are going this side because the x value will be to the left of A. A is already 1. Right, so y is n y2 plus n y1 over n plus n. Right, so use the point, the left ratio value with the right coordinate and the right ratio value with the left coordinate. So -1 times 2 plus 3 times 4 over -1. Sorry. -2 plus 12, which is 10 over 2. So the y value is 5. And looking at my diagram, that's a reasonable answer, isn't it? Okay. So if you put the minus sign on the 3 in the ratio and leave 1 as positive, you're going to get the point on the other side of B. Okay, on that line direction that it's going. Okay, so if you are just asked that question straightforward and you're not told anything specifically about which side, alright, you can do either one or have to mark them both as correct. Okay, but if there is further information in the question, and I'll let you look at it before I say anything, alright, you'll have to work out which side you're going to use. Alright, go from there. So therefore, P is the point -1. Okay. Right, I'm going to see next lesson for you. Right, so that's exercise 7.9 and we can start 7.10. Right, I'll finish that last sample up on Friday's lesson and decide where the rest of the lesson's probably going to be a working lesson because I'm not going to get through enough. Actually, no, there's a bit before that. We'll probably start parametric on Friday as well. Right, so those two exercises shouldn't take you very long to do.